Students, this is question number 20. We have a square and okay, and this is the diagonal. This is A, B, C, D. The distance is KCM. Now I need to draw the sector arc. So there is an arc like this. This point is M. This point is E. So ABCD is a square of side length is equal to KCM. M ABCD. So this is actually given as ADCB. So MDE is a sector of a circle and with center D. E lies on diagonal BD. M is the midpoint. M is the midpoint of AD. Now all of this region is shaded in the figure. Now we are asked to find the percentage of the shaded region of the square. Okay, now this is a solution. I'm going to start the solution here. Solution. Foremost, area of the square. So what is the area of the square? Is side into side. So what is the length of the side? K into K is K squared square units. So this is the area of the square. Now sector area. Sector area is given as the following. So it's going to be theta over 360 into pi r squared. Now if you see here, this is actually 90 degree and clearly BD is a diagonal. So this angle is going to be 45 degrees. So this means 45 over 360 multiplied with pi into, now M is a midpoint, right? So clearly this distance is going to be K over 2. So this is known. So you can substitute that value K over 2 squared. Now 45 means I can utilize the following table. Say 9 divides here 5 times, 9 divides here 40 times. So 5 means it's going to be 8 times. So this is going to be pi times K squared times 4 times 8, which is rewritten as pi times K squared times 8 4s are 32. So this is going to be the sector area. So we are actually obtaining the shaded area. So the required area is going to be area of the square minus area of the sector. So area of the square is K squared, sector area is pi times K squared over 32. So you take the LCM as 32, this is going to be 32 K squared negative pi times K squared. So you can take K squared out. If you take K squared out, you get 32 negative pi divided by 32. So this is the shaded region, shaded area, right? So now we are asked to get the percentage. Now to get the percentage of the shaded region, now this is with reference to the square, right? So to do that, or to obtain that, we need to take k squared of 32 negative pi divided by 32 divided by k squared multiplied by 100. So k squared gets cancelled. So the final solution, I'm going to write it over here, is going to be 32 negative pi divided by 32 multiplied by 100. Okay, you can either write it like this, or you can just divide by 32 both the components and write it. Of course, I think this is the better way to represent, and we move on to the next question.